The next area that we're going to take a look at is the actual center drill tab, and this is where we can specify the type of drilling that's going to happen. As we all know, we have drilling, spot drilling, pecking. We can do variable pecking, we can do high-speed pecking. For center drills, some of this is not going to apply, but it's good for everyone to see and understand that if we're doing drilling, and depending upon your tools, if you have through the spindle coolant, you have the ability to maybe do high-speed pecking. We could just set this for regular drilling and give it a depth. We could also do spot drilling, and then you'll see that you get a dwell here at the bottom. If I change this to variable speed pecking, I can set the first peck amount and then every other amount that goes with it down to depth. This is really easy to use. Same with high-speed pecking. High-speed pecking is just going to determine your rapid in and out before it actually goes to feeding. For our example, we'll just leave it at dwelling. We'll leave the dwell, or we'll set it to drilling, and we'll leave the dwell at 0. The next tab we're going to look at is the NC tab. And what the NC tab does is it gives us the ability to see how everything is going to be calculated. So for example, you can see we have a pretty big bounding box of stock on here. Normally we'd bring the stock down a little bit, or we would face mill this off first, but we're looking at the drilling feature right now, so we'll make the assumption and understanding that this has already been machined off and we're just getting ready to do drill features. So in the drill features, or the NC features, and this happens for contours, roughing, any type of feature that we have for milling, we have different areas we can set. By default, everything is always set to top of stock as your clearance plane or your rapid plane. And what that means is the rapid plane is going to be how far above the stock it's going to run. And this gives you clearance for like toe clamps, things of that nature, so we don't accidentally wrap it across a part and snap a tool off because there was a holder in the way. By default, it's set to top of the stock, or what you see out here, the blue shaded area, and then it's going to be 1 inch above that. You have the ability to use this information and customize it to reduce tool time and really make things efficient, but by default it tries to make itself as easy as possible to make sure we don't hit anything. You can also see the clearance plane is 0.1 above the top of the stock. So it's going to read this 1 inch above, and then it's going to go 100 thousandths above that before it actually sees it as clearance with the tool. And where that comes in handy is if we go back to our tool feature and we look at the mill holder, you can see if all of this information is entered correctly, then it knows the exact length of the tool sticking out of the holder. So when we come over here and we figure out the clearance and the rapid, if we enter all the information like how the tool is set in the machine, we don't have to worry about where that tool is going to be because everything is already calculated for by the software. The only time you would ever get into an issue is if you did not correctly put the math in to CamWorks based on how you're actually holding the tool in the real world. So if you tell CamWorks the tool is sticking out 2 inches, but in real life it's sticking out 6 inches, there's going to be some discrepancy on how the G-code is put because CamWorks isn't going to know that that tool sticks out 6 inches from the part. So how it gets set up is pretty important.